What is the purpose of a computer? Simply put, its purpose is to execute program. Without software to run, a computer sits idle without no task to perform. A program, commonly referred to as software, as opposed to the physical hardware components, is essentially a collection of instructions that tells the computer exactly what to do. These instructions are written in programming languages such as Java or Python, and they must be highly specific and detailed. For example, if you want a computer to accept two numbers from a user and determine which is larger, you cannot simply write input two numbers and display the greater one. Instead, you must break the task into precise, step by step instructions forming an algorithm. In this example, scanf reads input, printf displays output, and if handles decision making. Each language carries its own unique syntax, often appearing unusual to beginners, such as the use of AND before variable names, semicolons at line endings, and format specifiers like %d. Beyond executable instructions, programs also require definitions such as variable declarations, functions, methods, and classes. Software broadly falls into two categories: system software, the operating system, and application software, programs used for specific tasks like word processing, web browsing, or gaming. Typically, professional software engineers develop these programs. However, as you learn programming yourself, you may create your own tools. As an IT student, you will work with scripts, short programs designed to support systems or application tasks. For instance, you might write a bash shell script to automate the creation of user accounts, or a Perl server-side script to scan URLs for security vulnerabilities. Without human involvement, a computer would have no purpose. It is a user who initiates activity, directing the machine to perform tasks now or at a scheduled time. This interaction happens through input-output devices. Today, we take interactivity for granted, but in the early days of computing, roughly the 1940s through 1970s, virtually all processing took place without any real-time human involvement. Users would set up a program, define its input source and output destination, and then wait, sometimes for hours, to see results. The profile of a typical computer user has evolved dramatically alongside the technology itself. Initially, the only users were the engineers who designed and built the machines. As cost fell enough for organizations to purchase computers at prices in the millions of dollars, specialized employees received training to operate them. Personal computers arrived in 1970s and making a turning point. Yet it was not until graphical, window-based operating system emerged that ordinary people could begin using computers without formal training. Today, virtually everyone interacts with computers, often without realizing it, whether programming a GPS device or using an app on a smartphone. Computers were once unmistakable, enormous, prohibitively expensive machines weighing tons and filling entire rooms, requiring climate controlled environments and specialized facilities. Users never touched the computers directly, they communicated via terminals and networks. With the arrival of personal computers, ownership became accessible, and many people welcomed computers into their homes. Local area network and telephone based telecommunications allowed computers to connect and share data. The Internet, which debuted in its earliest form in 1969, became commercially available to home users in the mid 1990s and initially through slow dial up modem connections. Today, computers are nearly impossible to identify by their appearance alone. They exist as mainframes, desktops, laptops, notebooks, tablets, handhelds, and even smaller embedded devices. Connectivity has transformed equally. Wireless access means you are no longer tethered to a telephone port at home. You can browse the internet from a coffee shop, a park, or a moving vehicle, provided cell coverage exists. We now inhabit a world of near instantaneous global communication, home to tens of billions of processors, most of which can communicate with one another. This marks a remarkable shift from an era when computers were counted in the millions. So, this introduction to IT servers as a foundation for the chapters ahead. which explores a wide range of technology related concepts. Early chapters examine computer hardware components, what they do, how they function, and how they interconnect. Understanding the purpose of components like RAM or a processor helps you make informed decisions, such as when to upgrade memory or how to assess CPU performance. Binary numbers are also covered, primarily to support your understanding of computer networking concepts. The text then shifts focus to system software, comparing two widely used operating system platforms, Windows and Unix or Linux. Topics include file systems, user accounts and permissions, processes, and services. Linux specific subjects such as the bash shell and regular expressions are also explored. Various historical timelines are woven throughout, covering the evolution of hardware, operating systems, programming languages, Linux, Windows, and the Internet to help you appreciate the extraordinary pace of technological change and gain perspective on where the field may be headed. Later chapters address computer networking from multiple angles: the logical structure of networks, physical infrastructure, communication protocols, and common networking software. Additional topics include software management, particularly installing open source software in Linux, programming with shell scripts and DOS, information management, information assurance, and cybersecurity. The final chapter examines career pathways in IT and the professional responsibilities that come with working in the field.